Welcome to the second in the event series titled Climate Change, What Does It Mean for Southern California? This is presented by the UC Thelma Hansen Fund. So the second slide shows how you can participate today. Please do type your questions for the speakers into the Q&A on your Zoom ribbon bar. It's usually at the bottom of your screen. And the moderator will ask those questions at the end of each presentation. We will offer an extended question and answer period at 5:30 if there are more questions for the presenters than we have time for at 5:30. So we'll probably go until 5:45 or 6 if you're welcome to stay, or not if you have other commitments. If you do have comments or discussion, please add them to the chat, and please add, if you want everybody to be able to see your chat, please change it to panelists and attendees by clicking on it. Otherwise, it just comes to the panelists who the speakers are. And now I'll introduce our host today is Annemiek Schilder. She's the director of Ventura Cooperative Extension and the Hansen Research Extension Center.
Okay, thank you very much, Sherry, and good afternoon, everyone, and welcome to the second day of our three-day Thelma Hansen virtual series on climate change and its impacts on Southern California. As Sherry mentioned, this is sponsored by the University of California Thelma Hansen Fund, and I'm really excited to report that we have over 450 people registered for this series. So welcome, and I'm sorry I can't see you, but know that we're happy that you're here. For those of you who did not attend yesterday's session, my name is Annemiek Schilder, and I'm the director, as Sherry mentioned, of the University of California Cooperative Extension in Ventura and the Hansen Agricultural Research and Extension Center in Santa Paula. And just to summarize, yesterday we started off with a message from California State Assembly member Steve Bennett. And then we had a talk, a very nice talk by Dr. Daniel Swain, a climate scientist with UCLA and the Nature Conservancy, who talked about current and predicted changes in California's climate. For instance, he talked about the role of warming air in creating drought conditions, but also in increasing the likelihood of extreme precipitation events during the winter season, which may result in flooding. And as an example, he mentions the Great Flood of San Francisco of 1862. He also talked about a dramatic increase in the severity and scale of wildfires now that offshore wind season overlaps with drier springs and falls. And I think we learned a lot. And if you weren't able to attend or listen to it, we did record it. And so even for those who may want to go back and listen to it again, we will have a recording of all our presentations. Next, we had Sarah Mae Nelson, who is a University of California climate science educator from Elkos Ranch in the Half Moon Bay, and she spoke about the UC Climate Stewards, which is a new course offered by the California Naturalists, which is a volunteer organization very similar to the Master Gardeners of the University of California. And she discussed how the course prepares volunteers to engage the local community in communicating and responding to climate change. It's also very interesting. We then had an extended question and answer period to address additional questions, which we will do again today, as Sherry mentioned, for those of you who can stay. And if there are more questions, then we can answer in the period right after each presentation. So today we will focus on agriculture and impacts of climate change, and we'll have Dr. Tapan Patel, who is based at UC Merced, talking first, followed by local perspectives by Dr. Ben Faber and Nikki Anderson, who are both work at our office in Ventura. And our moderator today is Matthew Shapiro, who is our range and livestock advisor, covering both Ventura and Santa Barbara counties. So I'll pass the reins to Matthew.
Thank you so much, Annemiek. It's a pleasure to be with you all here today. I'm happy to be moderating this afternoon session. I'll be speaking tomorrow, but am again happy to be moderating today. As Annemiek mentioned, we have a great lineup of speakers, and I think we'll get right to it. I will be introducing each speaker, and then after the speakers conclude, there'll be time for questions, both immediately following the speaker, and then as has been mentioned before, there'll be a Q&A session at the very end. So the first speaker we have this afternoon is Dr. Tapan Patel, and he's a UC Cooperative Extension Specialist in Climate Adaptation in Agriculture, and he's based out of UC Merced. He'll be talking about climate change trends and impacts on agriculture in California, and hopefully specifically in Ventura. So Dr. Patak, are you ready with your shared presentation?
Sure. Yeah, let
Excellent.
me share my screen. Well, thank you so much for the introduction, and thank you for inviting me to be the part of this great webinar series. I'm happy to be here, and thanks for joining in. So today I'm going to talk more broadly about climate change. So yesterday the Daniel Swain talked more about the statewide climate change and what it means from extreme weather conditions and temperature and precipitation events. I will touch somewhat on the trend side, but then I'll talk more broadly about how it can impact agriculture in California. So I'm an cooperative extension specialist, but I'm an ag engineer by training and have experience in applied climate science and agriculture and work on various climate and weather applications in agriculture. So, this is not new to this group, and I'm probably preaching to the choir when I talk about facts about California agriculture, but I thought if we are talking about agriculture, it's important to show the scale of agriculture here compared to US in general and even globally. So we have a very unique Mediterranean climate which allows a variety of crops to grow across the state. So we have almost 70,000 farms and ranches across the state, producing more than 400 commodities, and the farm gate value itself is about $50 billion. And so if you compare it with other states, California is much ahead of the rest of the United States in terms of the farm gate value itself too. So when you compare the land, roughly about your total 43 million acres of land and only about 9 million acres of irrigated land. And so it's more concentrated production agriculture in the state. It's not new that, California is a leading producer of a lot of commodities and 2/3 of fruits and nuts production and 1/3 of the vegetable production in the state. These are the top 10 commodities. They do vary year to year depending on their values, but many of those specialty crops are not just unique to the United States, but even globally. So some of these nut crops, for example, California is a leading producer of those, and these are just the values, and it shows that how significant the values are for certain crops. So here's a very brief outline of my talk. First, I'll start with a few climate basics that Daniel Swain also touched base yesterday, and then talk about observed and projected impacts on certain climate variables, temperature, precipitation, extremes, snowpack, etc. But then how does those changes are impacting or are projected to impact agriculture? So it's ranging from yield decline to chill accumulations, growing season shifts, pest and disease pressure, etc. Then I also wanted to talk very briefly about a project that I'm getting started on with the US Department of Agriculture funding, is to create how can we better utilize climate and weather information and package it in a way that's it's more useful to the agricultural decision makers. And so how can we convert raw data into something meaningful decisions. And so that's our effort, and we are just getting started on this. So I'll briefly mention about that and conclude with summary and what sort of research directions state needs to take when it comes to climate change impacts. And it's an, when you think about California agriculture, it has to be an exhaustive list. And so there are only a few points I can mention, but I'm sure there are many more. Okay, so I'll start with this very simplified or complicated differentiation between variability and change. So there are two slides here. The top one, it says multivariate ENSO index. It's one of many indices that define El Nino as an oscillation. And so there are many other indices that are based on similar aspects, but their calculations are somewhat different than the others. So this is one of the ENSO indices. The bottom time series is called Pacific Decadal Oscillations. And so both of these indices are showing equatorial sea surface temperature variations. So the orange is when the oceanic temperature is warmer than normal, and the blue is when it's cooler than normal. And so when it's warmer than normal for a certain time frame, that phenomena is referred to as El Nino, and when it's cooler, it's La Nina, right? And so that's how this ENSO indices are defined. But the Pacific Decadal Oscillation has somewhat longer oscillations. And so if you look at the time scale, when you see multivariate ENSO index, they do vary from warmer to cooler, anywhere from 6 months to maybe 18, 20 months. So the time frame is shorter. And decadal oscillations, their oscillations are somewhat longer than the ENSO oscillations, but they still are oscillations, and they do vary from decade to even multi-decade. But they are both considered variability. So, they do influence climate across the globe one way or the other, and their magnitude is different depending on the location we are talking about. But their influence on climate is still categorized under climate variability. So by definition, climate variability is a measure of short-term climate fluctuations above or below their long-term average, right? So it's the long-term average is maybe a 30 years average, and the variability is more of a fluctuations around that long-term average, whereas the climate change is more of a continuous change, and the continuous change has to be statistically significant in order to quantify as a change per se. And so it doesn't have to be an increasing change. It could be a decreasing change depending on which variable we are referring to. So for example, when we talk about the temperature, there is an increasing trend about the temperature increases. But when it comes to snowpack, for example, then it could be a declining trend. And so depending on the variable, so the climate change is more of a continuous change, and variability is the fluctuations. So the major difference between variability and climate change is a time frame that we look at. So it's variability is more of a shorter time frame, and climate change is more longer term continuous change, 50 to 100 years somewhat. So that's kind of the difference when it comes to variability and change. Just to give you an example how El Nino can impact climate across the globe. So during El Nino and during the winter of El Nino, If you see Southeast Asia, you can expect warmer and drier conditions as opposed to southern United States, where it's more cooler and wetter conditions. Northwestern US and Canada region, it also, you can expect warmer conditions during El Nino winter. When you talk about El Nino summer, you can see almost there is no connection to the entire United States in this figure, the bottom figure, which is June through August. And so during summer, there is almost no connection to El Nino. But if you look at southern South America and parts of Australia, India, and Southeast Asia, you can still expect those influence of El Nino during the summer time frame. And during the La Nina, almost the effects are reversed. So this is just one example of how this natural variability can influence climate. Natural variability in the oceanic temperature can influence climate across the globe. So let's talk about the warming trend globally. And then this is not new to anybody in this group, that we are experiencing warmer conditions as we move forward. All the blue color you see is a 5 years moving average. And you can see the years changing on the top right corner. And as we progress towards the recent years, you start seeing more and more orange, which is warmer than normal conditions. And every single year since 1970 onwards has been characterized as a warmer than normal conditions in a global context. And so this is, there is another updated version, which this one ends at the 5 years moving average from 2013 to 2017. But you can see that, in the recent years, we are going towards more warming trends across the globe. So what's happening in California? This one is more of a historical picture. So you see different climate zones, and on the figure on your left, which is California divided into different zones. As you can see, for example, San Joaquin Valley, which is G here, rate of increase in the maximum temperature is not that significant. It's only about 0.5 degrees Fahrenheit per century. But look at the minimum temperature increases. So it's roughly about 2.5, 2.6 degrees Fahrenheit per century. And if you compare it to the maximum temperature, the rate of increase in the minimum temperature is substantially higher. And that's same with, if you see Sierra Nevada region, it's the same situation, that the rate of increase in the minimum temperature is very high compared to the maximum. And there are a lot of consequences when it comes to Sierra region. One of the direct impact is on the snowpack and the snow accumulations, right? And so there is a great influence on that aspect. If you see South Coast, that's where the increase in the minimum temperature is the highest. It's roughly about 3.5 degrees Fahrenheit in the last century. So this record is from 1895 to 2017. So it's more than 100 years. And the rate of increase in the minimum temperature across California is higher than the maximum temperatures. And that's the same information in a different context. So if you see this vertical line, which is a baseline temperature from 1949 to 2005. So that's kind of the 50 years, somewhat 50 years, 55 years of records. And compared to that, how much deviation you're getting in terms of the maximum and minimum temperatures. And so as you can see, orange is the maximum temperatures, and the deviation from that average is anywhere from 0 to 2 degrees Fahrenheit, whereas the minimum temperature deviation is from 2 to 4 degrees Fahrenheit. So, these changes across the century or across some time frame can have a great influence or negative impact on agriculture, and I'll talk about it in the next half. So let's talk about the precipitation trend. Here I have Sacramento, Northern California, and Ventura, Southern California, in the time series of a precipitation. So it includes both historical years as well as the future projections. And I pulled this slide from CalAdapt, which is the great website. A lot of agency collaborations and also the university collaborations to get all the climate projections to make some meaningful data creation for local conditions. So in this figure, as you can see, there is no trend, even historically or into the future. And in this case, I chose 4 different GC and general circulation climate models, and none of the models are showing any particular trend, either wetter or drier conditions. What it shows is a lot of variability. So as we progress into the future, even if we are not confident about the wetter or drier conditions, what modelers are talking about is we are going to expect more and more variability on the both extremes, drier and wetter. So in general, California will be vulnerable to both flood and drought conditions now and as we move into the future too. Another interesting information from these models is the entire wet season is shrinking. So even if we are going to receive same amount of rain, it'll probably come in a more intense single day precipitation type events. And so, there is a greater risk on that aspect, even if we get the same amount of rain. And so there is almost no confidence in terms of saying that whether California will be in a drier or wetter conditions, at least based on the current information. So if we put the temperature and precipitation into these 4 categories: dry hot, dry cold, and wet cold, most of the recent years are either in a dry hot or wet hot category, which means that in general, the recent years are going to be hotter than normal. But more specifically, this paper was probably published in 2017, and so they're using data till 2014, and based on that information, if you see those red dots, those are the recent 15 years when it was published. And so maybe 8 or 9 of those 15 recent years are in the dry and hot category. And so, the California went through the drought, and many of those years are falling in the dry and hot category. But California is going to expect more and more dots in top 2 sections, dry hot or wet hot. So extreme heat is another very big concern from many aspects and many sectors. And California, agriculture is also much more vulnerable to extreme heat conditions. I again use CalAdapt to pull it for Imperial Valley, which is the main vegetable production region in Southern California. And the extreme heat threshold is defined as maybe about a 97 or 98 percentile of the time frame that they looked at. In this case, from 1960 to 1990. So during that time frame, the 98th percentile is maybe around 112, 113 degrees for imperial region. So this is a very region specific, right? The extreme heat threshold. So what this slide is showing is that historically, there were roughly about 4 days where temperature was exceeding 104 or 112 degrees Fahrenheit. As we move into the future, under high emission scenario, in this case, I chose the high emission scenario, and I'm only using one general circulation model to show the kind of the trend it's going into. By 2070 to 2099, we can expect roughly about 79 days with temperature exceeding 112 for the Imperial Valley region. And so there's a huge steep upward trend in extreme heat events happening in this region. And depending on the location, this intensity could be different, but everywhere you are seeing this increasing trend in extreme heat events happening across California. And not just the number of events that is concerning, but also the timing of those extreme heat events. So this is again for Imperial Valley region. As you can see, most of the recent, I mean, if you look at the historical years, so from maybe 1950 until now, most of the extreme heat are concentrated around June through September. So mostly around the summer time frame. But as we go into the future, the summer becomes denser, which means that during the summer, we are going to see more of those extreme heat events happening, but the extreme heat event will start as early as May and last as long as October or November. And so, you know, some of those crops, they have this optimum planting window and an optimum, you know, growing season time. And then so that is impacting that time frame. But also, you know, there is another significant impact that would be, you know, human health impact and impacts on the farm workers and those kind of things. So that's another indirect impact impacting agriculture production. Snowpack is our natural water storage, and I pulled this from the Department of Water Resources website. If you compare with the the historical records versus the low and high warming scenarios, we can expect to lose roughly about 40 to 60% of the snowpack compared to the historical range. And that is based on our current understanding of the warming. So if this warming trend is even higher than what we expect now, then the impact on the snowpack could be even more concerning. Okay, so we did talk about impacts, I mean, the trends in temperature, precipitation, extreme heat events, and impacts on the snowpack. Now let's talk about how those trends could potentially impact agriculture. So let's take a global look first. If we think about rice, wheat, maize, and soybean, so the rice, wheat, corn, and soybean main staple crops, they comprise of roughly about 60 to 80% of the calorie consumed. And you know, if you compare it with the sub-Saharan Africa and South Asia and other region underdeveloped countries and the regions, these numbers could be higher. And so these are the main crops. And we mentioned about this increase in the temperature. So there was the paper by Lobel that where they compared, what about 1 degree increase in the temperature? How does that impact these main crops across these regions? And as you can see, I don't want to go into the detail of the table, but what I want to show is that even with the 1 degree increase in the temperature, 1 degree Celsius increase in the temperature, um, yield impact could be anywhere from 2 to 3% decline to all the way 21% decline. And so, especially in this countries where production is also scarce, that can have a pretty significantly damaging impact. And so that's just one example of it. If we talk about California, we have especially looking at impacts of temperature on the yield, there is not a lot of information out there other than empirical relationships with yield, with temperature, and other variables. And so there is some research gap there, but there was some modeling work done on this, the few included crops here. And as you can see, alfalfa, for example, doesn't show any negative impact under both low and high emission scenario. Safflower has a little bit negligible impact, but corn, tomatoes, rice, wheat, cotton, and sunflower start declining with the increase in the temperature. Now, this is a modeling study. Again, I want to emphasize is that they haven't considered any management or adaptation measures, so that do influence this yield numbers. So the actual decline is not important, but what's important is to see how temperature can have this negative impact on the yield itself. And another concern is that water is the biggest factor in California and what we grow here. It's considered no water stress condition. So if you include water stress, that can change the whole game of this yield curves. And so, I just wanted to show that your temperature can have this kind of impact, but these numbers could vary. So chill is another important variable for certain specialty crops. They require certain chill hours to break their dormancy and continue with the flowering and bud break uniformly. And so that chill is a number of hours below certain temperature threshold, and there are many different ways in which they are calculating the sufficient chill. One of them is called chill portions. That's where most of the tree physiologists are recommending. And so there was a paper that talked about impacts of chill, impacts of climate change on chill. As you can see, this is the central value on a horizontal scale. If you compare 90-50 range, in which you can have roughly 70 to 80 winter chill portions, and if you compared with the 2080 to 2099 figure, you can only get 30 to 40 chill portions. And so it's almost half. And so if we are referring to high chill accumulation varieties, that's where you can see pretty significant impact. So I also want to emphasize, talk about this particular study that the research scientist who is working with me, Ning Zhang, she is looking at, so this is not a climate change impact, but she is looking at how this different teleconnection indices, El Nino Southern oscillations, Pacific decadal oscillations, or other atmospheric oscillations can influence temperature across California. And does it provide any early indication of whether I'm going to get enough chill for the coming season or not? Just to give you one example of this impact is the figure on your left. It shows when the PDO, Pacific decadal oscillation, the figure I showed you in the first couple of slides, when it's in a positive phase, you can expect to get more chill in that season, during that season when the PDO is positive. But what if the PDO is negative? The entire Center Valley is red, which means that the number of chill you can expect during PDO negative phase is lower than they normally get during the mean time frame, which is 30 to 40 years time frame. So that's an interesting research, and I just wanted to show how this variability can impact chill accumulations from that angle. Length of the growing season. It's a time from last spring freeze to first fall freeze. So that time frame is increasing because our winter time, or the minimum temperatures are increasing, and so that expands that time frame from last spring freeze, first fall freeze. So in general, there's 10 to 14 days more days of frost-free season, but for California it's even higher. So you can expect 3 to 4 weeks of frost-free season, and so it's a longer growing season. But not to confuse it with the time frame from emergence to maturity. So we did a modeling study on the processing tomatoes in the valley, top 5 major processing tomato producing counties in the valley. What we found is that with this increase in the minimum temperature, the increase in the temperatures in general, what it does is that you can reach different growth stages faster. So you can reach maturity much faster under warmer temperature conditions. And so what we found is, on an average, maturity is in the processing tomato comes 2 to 3 weeks earlier than compared to the historical records. And so that kind of shifts the whole phenology for this particular crop. And I'm giving you some of these examples for the valley, but the phenomena can apply anywhere. And so if we are seeing this increase in the temperature, there's a direct impact on the physiology itself. In California, we do have a lot of concern about frost, and there is some good news with climate change, is that you can frost freeze. I mean, so the risk to the frost exposure will decrease substantially under future climate. But not to confuse it with year-to-year variability, we will still see a lot of years where later frost can start damaging crops. But this is more of a general trend that the frost exposure is going to be less and less of a concern. I mean, the frost risk is less and less concern as we talk about the future. So this figure shows frost exposure at 2 degrees Celsius in a early 21st century. That frost exposure is reduced anywhere from 25% to 50%. By mid-century, that is reduced from 50 to 70%, 75%. So there is a steep decline in frost risk across California, and then that could be a potential for adaptation to several regions where frost used to be a concern. And there could be some potential there, but that also comes with some other consequences that I'll talk about. Temperature also have a significant impact on pest disease and weed pressure, and then that's very much of a concern across the state. So we recently published work on navel orange worm, which is a major pest for walnut, almond, pistachio in the valley region. What we found is that these navel orange worms reach their generation faster and faster, and so during the growing season, you can expect to have even more generations of navel orange worm damaging the nut crops. By till 2005, there were probably one or two Southern California counties where navel orange worm, fifth generation of navel orange worm was visible. But as we move into 2070, 2080, 2099, and 2100, almost the entire valley will start seeing the fifth generation of navel orange worm. So there is, we talked about the frost exposure. Those frost sensitive pests, they are going to survive because during the winter, and that can start damaging crops even earlier in the season. So even the biofix, if it was happening in April or May, it can start in February because they did survive the frost. Increased rate of development and potential northward migration of pests can happen, and with this temperature and CO2, you can expect more and more weight pressure as we move into the future. So these are the types of impacts that that is potentially going to be a concern in California. I want to switch gear and just to briefly talk about this Cal Agroclimate project. So these days we have so much information about raw weather data, climate data, or any type of those data set, but there is not much done on how to convert this information into meaningful decisions. And so we are starting this project where we are gathering clientele inputs on what type of decision support tools are important for them, and start creating web-based decision support system that is very crop specific and region specific. So some of the example of tools that we are in the process of developing is heat advisory system. So getting information about the heat risk 7 to 10 days earlier, and what sort of heat mitigation depending on the crops you choose. And so getting those kind of portal of information at one place. Growing degree days tracking for crop phenology and pest detection, and then converting a lot of these indicators into more agroclimatic indices that can help growers make some meaningful decisions, or even the other users to make certain meaningful decisions. And so we are in a very early phase, but we are hoping to roll it out by fall or early winter and start gathering inputs. And so that's one way I think that effective use of climate and weather information can reduce some of the risk that we are seeing, and that could be a useful solution to at least some of the problems that we are having. This is one example. It's still under construction, but we are creating this type of information for the whole state. And so you pick your location and pick your temperature threshold, and it gives you the information about what's your frost risk and how many days consecutively you will see frost below certain below certain number, and whether that risk is going to be there for next 7 to 10 days. Same with the heat advisory tool, and we are planning to include the crops and crop specific heat and frost mitigation strategies. So I think that's probably one of my last slides. Just to conclude what we talked about is that climate change is in California is visible. I mean, we have been seeing this impact. If you look at this historical years, it's there, and projected impacts on agriculture is going to be substantial. So we talked about increasing the minimum temperatures maximum temperatures, precipitation. So there is no trend in the precipitation. There is a huge concern about extreme heat events and snowpack, and the water is the biggest resource, or the most important resource for agriculture, and there is a lot of uncertainty around that. There is a lot of impact, but some of this impact we talked about is crop yield decline and pest and disease pressure, and impacts on the pest and the impacts on the weed pressure as well. And so I think, in conclusion, if in order to improve this resilience, I think we need to look at more holistic solutions, and I think the solutions would need to come in from more collaborative fashion. In order for the future research, as I said, this is not the very exhaustive list, but I think these are the major the large scope ideas that we still don't know how these extreme events are going to impact crop specific impacts. And so I think we need to investigate those potential exposure to those extreme heat or extreme events, and potential solutions around that. We rely on models a lot, but many times those models are not ready. So I think we need to put a lot of effort in getting those models ready with parameterization and validation. And once they are ready, I think we can most certainly use them for a lot of studies, including crop performance under limited water conditions and water specific strategies. Although there is a lot of work done in California around irrigation, but I think if we have these kind of models that can most certainly help in that aspect. The last, but the very important point is that simply providing this scientific fact is not sufficient. I think if we are really making a solution, we need to take stakeholder perspective from the beginning of the process, and make them part of the solution itself. With that, I'll stop, and this is my information, my email and phone number, so feel free to reach out to me if you have any specific questions that I can't address here.
Thank you so much, Tapan. I'm sure that at this point, pre-COVID, there would have been thunderous applause from 175 participants, but for now, it'll have to suffice for me to thank you. We have a couple of questions in the Q&A, but before we dive into them, I just wanted to encourage the folks who are on the webinar today to go ahead and type in your questions if you want to stimulate conversation at this point. We have a little less than 10 minutes to answer some questions. Of course, if you want to reserve your questions for at the end, you can do so too. But I'll jump in with the first, and this is from Jim Thompson. He's asking, are there any future projected tipping points for California climate in which certain parameters, like changes in precipitation, wind, temperature, are expected to accelerate?
Yeah, that's a good question, and I don't know if I can answer like very straightforward. But I think I see more of the gradual risk increase, and I think it's the individual perception of how we perceive this risk and make those adjustments based on that. When it from ag perspective, it's not that these risks are in a way that we need to switch crops like tomorrow, and that'll make things make everything better. But I think it's if we are thinking about 30-40 years down the road, it's important to consider all these risks and kind of making your own trade-off to see where we stand, and then how can you use this information. So I don't know is more diplomatic answer to that, but there is no clear answer, at least in my mind.
Maybe asked a different way, I'm curious, do you expect, for example, cropping patterns and geographic and geography to change more in the next 30 years or in the 30 years that follows those?
Well, I mean, again, I mean, I think that's a gradual change. I don't think you'll see those shifts happening right away. I'm sure there, we will see some the cropping pattern shift, and so many times economics is a big factor, but at the same time, it's understanding of the crop and how these crops were grown in the region, and how these things are changing. For example, I mean, the chill accumulation is a big concern for a lot of high chill accumulating varieties. So it doesn't mean that we have to replace those crops. So there is some work being done on providing low chill accumulating varieties, and so if that happens, then not necessarily we are switching the crop, but maybe adapting to the new varieties. And so that kind of changes I am seeing that could start happening in the 30 years transition, as opposed to switching the entire crop. And so, but those kind of transition is more of a transitionary phase than happening right away.
That makes good sense. So Sabrina Drill, our UC colleague, has a question, and actually I was interested in this portion of your talk as well. I think it was based on the tomato research you were doing, but she's asking, if maturity is reached earlier, does that mean it could be reached as a smaller size for vegetables? And I'm sure that maybe differs between vegetables, but maybe in a generalized sense.
Very good question. Yeah. So in that particular research, we did not look at the physiology of the tomato, but if you see the crop physiology, and if you talk to the crop physiologist, you would get this answer that if the time frame on the phenology it reduces, there is a direct impact on the fruit or the yield and the size and those things. And so there is a good chance that with this phenology shift, or the time from emergence to maturity shrinking, has a positive correlation with lower size fruits or low yield accumulations. So I don't know about tomatoes because we didn't study in that paper, but the models do agree, and the crop physiology do agree that there could be an influence on the yield.
I do just want to jump down to this last question because it pertains to what you were just discussing. In addition to yield size, what about nutritional quality of the crops as
I
temperature might
don't
increase?
know. For that one, it's just a guess that I think it could be crop to crop difference, but I think that's a good question for crop physiologists. But but that's a great question. I'll try to dig it myself too, but I don't know the answer.
So we have, I think, time for one more question, and I want to assure folks that we'll keep these on the Q&A and that they can and will be answered after all the presenters present. But Francis is asking, who will generate the forecast products that you anticipate will be needed? And maybe I can add an addition here and just say, it sure seems like getting producers to co-produce the sort of products that would be most useful to them would be an advantageous part of this process. Maybe you can speak to that generally.
I didn't understand the question. So who, which are you referring to? The Calagro climate product that I talked about?
That's how I read the question.
Okay, so I mean, we are not generating the forecast. So I think what happens is that National Weather Service or the NOAA, National Oceanic and Atmospheric Organization, they are producing a lot of those weather products that are out there, but the formats or their raw formats are so complicated to understand. And so what we are trying to do is use that information, it's out there, and try to convert into different types of agricultural matrices that is more relevant to the growers or more relevant to the ag community. And so that's how we converted into creating this kind of the forecast based on the temperature variable forecast information that we have available.
Thank you so very much. I know that you'll be staying with us for the length of this presentation, for this webinar tonight. But for now, we should shift gears and ask our next presenter, Dr. Ben Faber, to turn on his video and bring up his presentation. Dr. Faber has since 1989 worked for the University of California as the Soils, Water, and Subtropical advisor, and he covers both Ventura and Santa Barbara counties. And in classic Ben fashion and humor, the name of his presentation is Heat, Wind, Freeze, Wind, Repeat. So with that, Ben, if things are lining up for you, if you wouldn't mind taking it away.
I would love to take it away. I can't get to my slides. There's this black strip that's going across the top.
Ben, if you click on the lower, can you see your presentation mode? Because we see them, you just have to put it in presentation mode. Can you see in the lower right your presentation little button? It might be
the icon just to the left of the minus sign on the lower right bar.
Right.
The minus sign.
Right below where it says weather.
What weather?
You say normal coastal weather.
Okay.
There you go. There you go. It might disappear.
Okay. Yeah.
There you go.
Okay. This is the craziest place in the whole wide world to irrigate because, you know, we've got this fog, that May, gray, June gloom that we used to get reliably. And last May, we had 118 degrees. So, but we have these clear days. And so, you know, finding the best way to educate people on how best to irrigate is so difficult here because, you know, so many people want to have a, you know, a roadmap, a cookbook, and you just cannot cookbook irrigation in the coast here. You've got to go out there and check it on your own. So this is the County Government Center gets about 18 inches of rainfall, and that's the average. But there's no such thing as an average year. It's either, you know, 3 inches or 50 inches. And just as an aside, Goleta in Spanish means schooner. So back in 1862, we had one of these 60-inch rains that caused mudslide and it filled in the harbor. So it's just an estuary now. But, you know, these events average out to 18 inches. And when we have rain, things are gorgeous and you really can't make a mistake irrigating. But when we have weather like now, where it's warming up and we're accumulating salts because that's what's in the water, eventually you'll see problems with growing things here. So when I first came here, Bob Brendler, who had been the 4-H advisor and then was the veg crops advisor, he was collecting weather data. And he told me that prior to about 20 years ago, you never saw avocados or lemons growing east of Sycamore Road. And this is a country road in between Santa Paula and Fillmore. And it froze so reliably there that nobody bothered to plant avocados or lemons. And now you can find them growing out in Peru. So the weather has changed. Okay, so Tapan mentioned something about chilling hours, chilling requirement. We had 2 heat events last year that our typical crop of avocados, Hass avocados, it's about 350 million pounds each year, where it's down to about 290. So we had a significant drop in yield. And it was these two heat events that really caused quite a catastrophe. And this is the weather pattern at Santa Paula, and it shows a variability in temperature. The chilling requirement, this is 45 degrees and below, it is changing. And we can grow mangoes now, which is really a tropical fruit. We grow historically subtropical fruit that you can't grow in Kansas or Fresno to a certain extent. We grow stuff that is Mediterranean in its climate pattern, wet winters, dry summers, and it typically would not get too cold in the winter and typically not too hot in the summer. And we got Santa Anas that would blow between October and March. Now we can see the Santa Ana condition happening just about any time of the year. So really it's changing. Turns out you cannot grow Hass avocados in Florida because the Hass requires between 50 and 100 chilling hours. These are the number of hours below 45 degrees. And if they don't get it, they don't leaf out right, they don't flower right, they don't fruit right. So they grow a bunch of other tropical avocados in Florida. They can't grow the Hass. But this shows you the variability that exists in the chilling hours alone between in the last 6 years or so. Okay, so here is the wind, the Santa Ana conditions. We are growing these vegetables and fruits that are extremely sensitive to heat. They don't like to get hot. And when we had that 118 degrees last spring, eucalyptus trees looked like they'd been torched. Redwood trees looked like they had a fire go through them. Even oak trees looked bad. And we'd gone from our average 70-degree weather to 118 degrees, and we had people turning on their irrigation systems in anticipation. We knew it was going to get hot. And the trees need to be fully hydrated going into a Santa Ana condition. But even then, a lot of trees got torched. So the Santa Anas blow in off the Rockies, go through the desert and pick up heat and dryness. Historically, we had 15 days and nights. Usually it was a 3 day, 3 days in a row, 3 nights in a row, where it would get below 32 degrees. There are many fewer days now. We had 2 freeze events, one at Christmas and one a little bit later after that, but they weren't catastrophic like they used to be. But those 2 heat events that we had last year, really, plants are not designed for 118 degrees. So what do we see with the heat that we get? Well, you see the fruit drop, fruit size is reduced. The trees actually shut down their photosynthesis. They close their stomata and stop losing water. They're trying to protect themselves. You see root dying, and you'll see the flowers falling off. So these are all related to not just avocados, but to lemons as well. So if we're not on top of our irrigation, we see things like bacterial canker, Dothiorella, which is a Botryopharia. It's a fungus disease. We see sunburn, we see black streak, we see actual death of growing points, and then we see this, what is often confused with salt damage. It's really this Botryopharia that is really goes after shallow rooted plants like blueberries and avocados. So we grow blueberries here, and we grow things here that cannot be grown in other places. And the blueberry here is what's called an evergreen blueberry. It doesn't go deciduous as it does in the Central Valley. And it allows us to harvest fruit virtually all year round because it's flowering and fruiting all the time. And it used to be up until about 6 years ago that California had the only blueberries on the market in February, March, April, May. Now we're importing that stuff from Michoacan, and we've lost our advantage. So we don't want to grow what other people can grow. This is sunburn damage on a loquat, and this resulted from last spring's heat. Basically, the cambium, the green part just below the bark, died, and so you see this the bark falling off. And you're going to hear all about fire tomorrow with Max Moritz. Something that I had never heard of before, and it's not for lack of looking. I called Air Pollution Control District, which was upstairs from us, and I called around. I called USDA, I called the National Fire Association, and I said, "What is in smoke?" Because there's a lot of weird gases in smoke, and one of the common gases is ethylene, and that's a ripening hormone that basically causes fruit to ripen. Well, I went out several cases, and this is what smoke damage was doing, smoke inhalation was doing to avocados. It caused all this fruit to drop off. You know, the ethylene accelerated maturation. Here's an example of pixie mandarins up in Ojai after the Thomas fire. Just all this fruit came tumbling down, and the heat from the fire caused this scorching. This is exactly what a lot of the trees looked like last spring with the heat spell. So what are we doing about it? People are taking heat seriously. They're installing these overhead sprinklers now to water cool the orchard. There's at least 5 growers in this county in Ventura County that have adopted this overhead sprinkler technology. And it can actually drop the air temperature as well as the leaf temperature. So the air temperature often is not even as warm as the leaf. And so you can drop the leaf temperature by as much as 10 degrees. And this means the difference between saving a crop or not. And using mulch. You're going to hear about mulch from Nikki Anderson. You know, just a little bit of mulch is going to reduce the amount of surface area that's absorbing the sun's rays, and mulched orchards we see cooler temperatures. And this of all things, this is from South Africa, but Mary Lou Arpea is doing a trial with avocados in the Central Valley near Hanford, where putting up this nylon mesh can in turn reduce temperatures. In South Africa and the Mediterranean both, they actually put it in to prevent hail damage to fruit as well as to cool them off. By the way, we're called a Mediterranean climate, but if anyone's ever been to Turkey, Egypt, Spain, Israel, Portugal, Italy in the summertime, it is not the same. It's hot and humid. You know, this is not a Mediterranean climate. This is California climate. Planting cover crops. Okay, cover crop is transpiring. It's cooling the environment. So we're seeing more and more people using cover crops. Windbreaks can actually cool orchards as well. So we're seeing people adopting new practices. For years, nobody ever pruned avocado trees. They just let them get 60 feet tall. Now trees are being kept at a lower height so that pests can be managed more easily. But we whitewash the trees. So anytime a tree has been being exposed, it had been in the shade, there's a high chance that you can get sunburning like you saw in that loquat picture. And so we'll make up a whitewash of latex paint and paint the trees. Okay, so in summary, we're protecting trees, but you have to have a healthy tree going forward. So the orchard needs to be designed correctly in the first place, and a healthy tree is always going to be better able to fight off heat. Successful irrigation is crucial. You need to get the water on before the heat event. Once heat arrives and you try and irrigate, the stomata are closed, and so the water does not move inside the tree. So you have to have open stomata for water to move from the soil into the tree trunk and out the leaves. And you get this cooling, same way that we cool ourselves off the sweat. Trees transpire. And you've got to get the water on before the heat event. We mulch trees, which helps improve tree health. And we monitor more and more soil moisture. People have to be on top of their irrigation. 80% of all the problems I see in agriculture are related to not enough, too much, or the timing is off. And then there's been a certain amount of work done on anti-transference that basically cover the stomata and reduce transpiration, but it reduces actual water loss from the leaf too. So it's kind of like a balancing act. You have to have some transpiration in order to get the cooling effect. But if you have too much transpiration, you'll get the leaf wilting. So yes, our weather patterns have changed here, and we have adopted certain practices that allow us to continue to farm as long as we have water. And so this is one of the issues that is coming up more and more. There's just so much water, and it's got to be divvied up amongst a whole bunch of users, and there's just not enough to go around. So that's all I got. Any other questions?
So Ben, do you want us to display your poll?
Oh, yeah.
There we go. There we go. So a couple questions here.
Yeah, so whitewashing with white latex paint is effective at preventing sunburn damage. True or false? And then Hass avocados have a chilling requirement of 5 hours, 50 hours, 500 hours, 5,000 hours.
Seems like an unfair pub quiz, Ben.
No, it's not fair.
While we finish the poll, maybe you can answer this first question. Tracy writes, avos require their chill followed by a warm trend. Is that correct for fruit set and retention? How will the climate temperature shifts affect that specifically for avocados? Okay, so we can grow apples here. Apples start with an A just like avocado. They have a higher chilling requirement than avocados. And so we get what's called a rat tail bloom. It's spaced out over many, many months. I've got an Anna apple at home that I get apples 8 months a year off the thing. And so if you don't get enough chilling, you get this extended flowering period. Avocados need cool weather, which we do have. Most chilling hours are done in the winter time, but we actually get a lot of our chilling in May and June through August, when we have nighttime temperatures that drop to 45 and daytime temperatures go to 80 maybe. So we accumulate hours during the summer as well. But you need to have 48 hours of above 50 degrees to get fruit pollination to occur, flower pollination to occur. So
So these poor Hass trees are flowering January, February, March, April, May. And then we get these little glimpses of 85 degrees in the afternoon, and that's when you get fruit set. So yeah, you need a combination of chilling hours plus warm temperatures during the flowering period.
How will climate change affect that, do you think? In
Well,
30 seconds.
in Florida, we're not going to be able to grow Hass. And everyone wants to eat Hass. They're planting Hass at high elevations in the Philippines. They're planting Hass in Guangzhou, China. They're planting Hass in Malaysia. I was on a Zoom phone call to Malaysia about 4 weeks ago, and they want to grow Hass too, but I don't know if they've got the right temperature regime. Anyway, so whitewashing with white latex, yes, that's what we use. And it's 50 to 100 hours of chilling that Hass needs. So
we're B- students, Ben?
yeah.
Well, thank you. We're a minute past our schedule.
Okay.
Thank you, Ben. I hope you hear the thunderous applause. I have a question for you, so I'm hoping you'll stick around to the Q&A session afterwards.
Sure.
And so with that, to be able to fit everyone in, I want to turn to Nikki Anderson, who I'm pleased to introduce. She is a relatively new addition to our CE office in Ventura County. She works as the community education specialist, and she's going to talk a little bit about healthy soils and the California State Healthy Soils Program. So Nikki, if you're there and if you have a PowerPoint that you can bring up and share, that would be excellent. You can take it away.
Thank you, Matthew. All right, we in?
You're in, you're great.
All right, good evening, everyone, and welcome to the Healthy Soils program portion of the virtual series on climate change. I'm Nikki Anderson, and I would like to begin by stating that I am speaking on occupied and unceded territory previously stewarded by the Chumash people, and the original inhabitants of this land are among the original leaders in regenerative agriculture. Today, it is known as Ventura, California. My background is in agriculture, not because I grew up in it, but because I became fascinated by its potential in being a tool, not just for social change and community development, but as we're here to talk about today, a powerful tool for mitigating climate change. My role at the UC Cooperative Extension is a community education specialist promoting healthy soils. And I cover Ventura, Santa Barbara, and sometimes San Luis Obispo counties. And I help growers apply for the CDFA's climate smart agricultural programs, which includes the Healthy Soils program. So how do I proceed? Does someone have to go to the next slide for me?
No, you should be able to, Nikki. So just, can you go with your down arrow? No?
Down arrow, there we go. Thank you. So the Healthy Soils program stems from a long line of climate change conscious legislation, part of the California Healthy Soils Initiative, which came out of cap and trade, and it's a collaboration of many state agencies and departments, as you see here, looking to promote the development of healthy soils among California's farmlands and ranch lands. And it's been going on for a few years, and it's only gaining more momentum, even at the federal level, as was mentioned a couple weeks ago at the House Appropriations Committee. It looks like climate smart agriculture and soil health practices are part of the administration's priorities. And while the concept is gaining traction, the implementation is still evolving. It's morphing and changing. So, it's a good thing. It's a reflection of the program's willingness and openness to respond and adapt and improve. And lucky for us, we've got a head start here in the West. California was the first to tie soil health to climate change, recognizing the powerful potential of photosynthesis, at least with legislation. And as a grant program run through the CDFA's Office of Environmental Farming and Innovation, I like to emphasize that it is focused on encouraging growers to try new practices that will improve their farm's resiliency instead of regulating them. So I hope you like acronyms. We've got a lot here. California launched 3 CSA. CSA is climate smart agriculture here, not community supported agriculture. And these all contribute to climate change adaptation. There's the Alternative Manure Management Program, AMP. That's for decreasing greenhouse gas emissions from livestock operations. We have State Water Efficiency and Enhancement Program, SWEEP. That's to improve irrigation efficiencies. And then the Healthy Soils Program. And so here you can see kind of the range of applications and possibilities of these programs, really trying to maximize the benefits. So, but we're not just reducing greenhouse gases and sequestering carbon. As many of you know, Healthy Soils achieve more than just this. While we can't necessarily control 118-degree weather, like Ben just pointed out, we can do our best to create a healthy living environment for our crops. So I want to emphasize the concept of stacking functions here. Healthy soils are likely to mean healthy plants, and the benefits of healthy soils include not just improving healthy plants, but also plant yields, reducing soil erosion, reducing on-farm dust, improving water and air quality, supporting wildlife habitats, increasing soil water holding capacity. And in areas where farmers are concerned with soil-borne pathogens, stepping back to look at soil health is a really good idea. And in addition to these warm, fuzzy environmental aspects, there is increasing evidence that show that healthy soils can also lead to cost savings as well. So through all of this, we're building more resiliency through necessary experimentation. Okay, so the Healthy Soils Program itself. Yes, its objectives are to increase the statewide implementation of conservation management practices and improve soil health, sequester carbon, reduce atmospheric greenhouse gases, and and improve resiliency. So there's 2 main sections. There's on the right, you've got incentive grants. These are aimed more for farmers, providing financial incentives for them to use some of the approved practices, of which there are 29 or 30, and then demonstration grants that are more geared for academics. And how to get out of the, all right. And I want to also clarify that the programs, as I mentioned, are changing all the time. So some of the things that are here for requirements and restrictions aren't going to be the same. But you have to have 3 years management data, control of the land. For the next 3 years, you have to take soil tests, 1 application per tax ID. For the incentive grants, I think the max grant is $100,000. For the demonstration, it is $250,000. So the restrictions include ongoing projects. So even if you have already been composting and cover cropping, you will not qualify. The Healthy Soils Program also does not include greenhouses or potted plants, and it does not pay for practices on land that are growing hemp or cannabis. So this is a graph, it's kind of small, but there's 19 projects listed at the bottom, and this shows the top 3 that received awards. So compost application is the orange one on the right with almost half, and then cover cropping is the yellow pizza, and then up on the top left is actually mulching. So those are the top 3. So yes, Ben, hopefully I have time to get to mulching. Cover cropping, one of my favorite things in the world. It increases soil organic matter, microbial diversity, it reduces disease and pest pressure, it helps with water infiltration, it helps with potential pollinators. And there's hundreds of things that the cover cropping does, and it also, you can get paid. It changes depending on your situation, but if you do it for 3 years, you can get paid about $106 per acre per year. And you have to plant those cover crops in the same place every year. Compost, you have to have a CDFA certified compost to produce on your farm. Lots of benefits of composting. And then mulching, very popular here, especially in the avocado orchards, as it happens quite naturally. And you can see that the payment per acre is quite high. And the payment per acre depends on what kind of mulch you're applying. So to wrap it up, here we have 600, the project's only, there's been 3 rounds and 646 projects have been funded so far. That is equates to 41.5 million grant funds awarded, and the proposed budget has 30 million going toward the Healthy Soils program for on-farm soil practices that sequester carbon. And then this is like just a little recap of what the Healthy Soils program has achieved already. 110,000 estimated metric tons of carbon dioxide equivalent sequestered each year, 23,724 cars taken off the road each year, and we've had these practices on 56,000 acres. And with that, I will conclude. This is my email. That's my name, and there's some beautiful citrus trees.
Nikki, thank you so much. In our program, we don't have technically a Q&A session now specifically for you, because I think largely that's because we're going to transition into a general Q&A with the whole group. I want to acknowledge that it's 3 minutes before the appointed hour that we were supposed to end, but partly based on yesterday's overwhelming feedback and questions, we're planning to extend this time. But of course, if you were only planning to be here till 5:30, we understand that you may and will leave. Of course, you could have left at any point, but we're happy that you stayed through the whole presentation. Let's go ahead. I know Tapan and Ben have been diligently and quickly answering questions that were written in the Q&A pod. If there are other folks who want to pose questions, now would be the right time. I think, Ben, if you don't mind turning on your video and sound, it would be worth, I think, returning to some of the questions that have already been technically answered in the Q&A, because I think it's maybe worth a little bit more discussion. We'll plan to go till at least 5:45 at this point, and we can reevaluate at that point whether we want to continue more. One question that came up a little bit, but in my thinking, maybe should have come.
Matthew, I'm sorry, it's Sherry.
Yes.
Annemiek just wanted to say thank you to everybody before, if anybody had to get off the call before we continue into the extended Q&A. So Annemiek, did you want to?
Yes, thank you so much. Well, I just want to be cognizant of people's time and want to make sure that we thank all the speakers. Tapan, Ben, and Nikki were wonderful. Very informative presentations. I want to thank Matthew for his great moderating skills, and also Sherry and her team of the program support unit for their help. So thank you for your attendance and attention, and we hope you can stay on for the questions, and also want to invite you to join us tomorrow for our session on fire and fire resiliency. Thanks.
Thank you, Annemiek. I apologize not giving you that opportunity to sign off before I launched into Q&A, but now that you have, I think we will. And a topic I wanted to sort of raise again was this issue of water. And Mary, about 40 minutes ago, talked about water being the elephant in the room. And I think both Tapan and Ben mentioned it at points, but it seems to me, so Mary's question is, water will of course determine much of what we can grow, whether there will be recharge of groundwater in the Central Valley. And I guess maybe to reframe that, or to ask a specific question to either Ben or Tapan, is it your thought that things like weather, temperature, rainfall, wind will be driving changes in cropping patterns and sort of be determining the future of agriculture in California, or will it more be water and water availability? What are your thoughts on that?
And labor.
Yeah.
Yeah.
You know, we grow high value crops that require hands. And somebody asked, what about the political social interactions? And I said, California Agriculture is a magazine put out by UC, and they have had some excellent articles in there about the impact of groundwater systems drying up and weather changes happening. So I'm putting in a plug for California Agriculture. You can find it online.
Yeah, I think water, as we all can agree, is the biggest factor or one of the factors. But I think all of the above. I mean, the temperature also has those kind of impacts, and water is not the only mitigating strategy, and so I think as we think of those changes, and as Ben mentioned about the labor, and so there's a lot of work now being funded about how automation can start coming into California agriculture, and more specialty crops, and then how automation can help, and because labor is going to be a bigger issue, and I think there's a human health aspect to that, and so I think a lot of the crops we grow, I think it's the high value crops, and then the term itself says high value, and so it's if there's value to the crop, we're we can grow as much as we can, but I think those are the factors going to affect, and water is most certainly one of the important ones. When it comes to the groundwater recharge, I think that's the direction we have to think about. I mean, those extreme wet years, we need to take advantage of the excess water, and rather than having it run down the ocean, if we can do practices that way we can recharge more. I think there are a lot of projects being implemented to see flooding the orchards, and does it damage the crops or not, and so those kind of the questions, if we know more, and when those extreme weather the extreme wet precipitation comes in action, I think we can take advantage of that. So
Ben, how many acres would you speculate have experienced a reduction in yield or total fallowing or crop change as a result of inadequate water in Ventura County?
I don't think to any great extent. You have to go into the Central Valley on the west side and see all these abandoned orchards, dying trees. Cropping patterns have changed. It used to be very common to have a summer strawberry crop here, and it's much less common because it gets so darn hot in the summertime. You have to have a cool, this mild climate that we're so famous for. You can't have 118 degrees and expect to grow summer strawberries. So, patterns have changed. So because of the labor issue, there's been lemons have gone in, avocados have gone in on the Oxnard Plain, which had strawberries planted to them.
So transitioning a little bit to that idea of changes in cropping pattern, Michael Delaney asked, is there research into alternate crops that are better suited for future climate conditions? I think this has been alluded to, and Ben, you note that new crops are being trialed all the time. I guess to expand on that question, will they be new crops, or will they be new varieties of the same crops?
Well, for example, we're looking at gem avocado. It's a brand new variety, and so that's going to replace some of the Hass. We're looking at new lemon varieties, new lemon rootstocks, new avocado rootstocks. But we do, we put in a coffee trial, we put in a tea trial. So yeah, we grow some really oddball things here, cherimoyas and lychees and longan and loquats, and So people are always, we use our climate to our advantage. We don't want to grow what Mexico is growing. We don't want to grow what Kansas is growing. We could never compete with the land prices here, the water prices, the water availability, the labor. You know, it's just, we are a very expensive place to grow stuff.
Ben, you've been in Ventura County for 30 years. You've seen a lot of cropping changes in that time. I guess one question is, have any of those in your mind been a function of climate change or water availability? And then as a follow-up question, you know, what does cropping changes in your mind look like in the next 30 years? Will they be more driven by climate change and water availability, or it sounds like to a certain extent, maybe more by social, political, labor issues?
Yeah.
You
know,
can you
if
speak
you
to
look
that?
at Ojai, you know, they are desperate for water up there. And a lot of people pull the water off their Valencia oranges there, off their mandarins, the pixie mandarins. I've seen abandoned avocado orchards. There's somebody is planting, I forget whether it's 40 or 140 acres of maguey, you know, the stuff you make tequila out of, because it doesn't take very much water. You know, dragon fruit's been promoted as being a low water requiring crop. There's also columnar cactus, beautiful pieces of fruit that actually has flavor. It can get by with a quarter of the amount of water that is used for avocados. So yeah, I mean, there's people are innovative and they're doing things, but if you don't have any water at all, and that's getting to be the case in places like Ojai, you're stuck. You know, you got a bunch of land that you can't do anything with.
Do you expect some of our crops to become tropical rather than subtropical in 30 years?
I saw jackfruit being grown in Long Beach about 2 years ago. You cannot, I mean, 20 years ago, you couldn't have grown jackfruit. And these are these massive pieces of fruit. You know, they each weigh about 40 pounds. I don't know what they're going to do with all that fruit. But, you know, when you go to the swap meet, they have jackfruit from Mexico and it's cut into slices. So, yeah.
So, can I ask Ben a question? So I was thinking, you know, when we were doing this frost exposure, and then we are seeing this, you know, frost risk being diminished in many parts. Are you seeing any areas where they're kind of growing more because of the low frost risk?
Well, I'll tell you, in Ventura doesn't like the two major growing areas for lemons are the desert and Ventura, Santa Barbara, to a certain extent, San Diego. Those crazy Central Valley guys are planting acres and acres of lemons because they've had a good freeze to remind them that lemons don't belong in Fresno. I don't know, but you know, when they do a trial, it's on 100 acres. You know, and you know, when we do a trial, it's on 10 trees. So you know, that's big farming there. Although it's not as productive economically as some of the farming is here.
So we've had some new questions roll in, and I want to give Nikki an opportunity to wax eloquently about her most favorite thing, cover cropping. So Neil here is asking, with cover cropping, how close to the crop do you get? I think he means spatially, but maybe also temporally. And what are the best varieties?
Well, this might be a frustrating answer because I only have more questions for Neil. What is he growing and where is he growing and what does he want to get out of the cover crop? So it really depends. You know, for an annual crop, you know, it's harder to incorporate cover crops. And for instance, if you're putting cover crops in an orchard or in a perennial system, then it depends what stage of life your plants are in. So he can reach out to me and email me. I'm sure I didn't answer it too, because I didn't know if Ben wanted to put his 2 cents.
No, go for it, girl.
So yeah, there's a lot, there's endless abilities. One of the things that I will be doing here is a cover crop trial to see if certain cover crops, certain things that previously have been referred to as, low performance cover crops, that might be ideal in another situation. So it's all very relative. So.
Great. There's another question here from Benjamin. We've begun to discuss it a little bit, but what are the wise crops for California coastal growers to plant considering the future of our climate? And maybe I can give both Ben and Tapan, what are 3 crops that you would encourage growers to consider given the climatic constraints that you're describing?
Well, if you'd asked me this question 20 years ago, I would have said blueberries. These blueberries in February were going for $80 for a 4 kilo flat, and that's serious money. Today, with Michoacan sending blueberries in, the prices are not, they don't pay for themselves. We grow a great sour lemon, so we can't grow sweet things very easily. We grow sweet strawberries, but this is still great citrus country, and we have Asian citrus psyllid, and we'll find some solution to that at some point. But I think this is always going to be a great citrus avocado growing country.
Tapan?
I don't know the answer to that, but at least I second what Ben said, and Ben's point about California can grow some of those unique crops. So I think understanding the feasibility and economics sometimes can create some great opportunities that might not exist. Given the water constraint, given the temperature constraints, and the drought and heat.
People are growing cannabis here because it doesn't take as much water as a lemon. But they're growing cannabis in Illinois and Iowa and Kentucky and Tennessee, everywhere. We're not going to compete with those places.
Yeah.
Tapan, I wanted to pick up on a thread that came up for me a lot during your presentation, but you just alluded to again, which is, for as much doom and gloom as there, in some respects, there is for California agriculture in the face of changing climate, it also seems like there's a lot of opportunities, strangely, to transition crops to, that agriculture, given its typical ability to adapt, may actually thrive, or at least persist, perhaps not as we know it today, but perhaps with just as much economic viability. Does that sound right to you?
Absolutely. Yeah. I mean, we have a lot of flexibility. I think it's, maybe certain risks could be associated with a particular crop, but even with the crop, that's why I stress on this point is this adaptation is crucial. I mean, it's not that you're stuck with this kind of risk that we are seeing with the climate change. It also can come with a lot of solutions and opportunities. And I think that's what it's more of a dynamic game than having a static, one crop and all. So it's if there's an opportunity for switching a variety, that could be more potential. And then especially, I mean, it's if you're thinking about this long-term orchards, then you definitely should think about those risks and then maybe find better opportunity where there is a low risk and high returns. And so I would say it's not all negative. It still comes with a lot of options. And California agriculture is not going to go away, and with the changes and risk we are seeing, it can work in our benefit if we can properly integrate into our risk portfolio.
Thank you. Changing gears just a little bit, Sabrina asked a question about specific studies about the impact of high heat days on the availability of agricultural labor. I also imagine she means here also maybe the health and safety of agricultural labor in the face of some of these more common extremes. Is anyone in this group familiar with studies like that?
Not me. Yeah, go ahead, Ben.
No, go ahead.
I mean, it's an interesting. So I'm part of this the newly funded project through UC multi-campus research, and that is specifically addressing labor issues and automation in California. And we had this discussion about the health issues and how this heat and other extremes can have impact. But it seems like there is, although that's a big issue and should be the priority one, but that doesn't come in a big priority from the decision maker perspective so far. So I don't know if it makes financial sense to whoever is planting. Unfortunately, that is what I heard, but I don't know too much about that.
Sabrina, you have the unusual ability to speak up as a former panelist. Do you want to follow up with any questions or thoughts there?
Well, I was just thinking about the health impacts, but specifically, are you going to be losing? We already have problems with the availability of labor in Ventura, and we might be able to switch to crops that do well with these longer growing seasons and higher temperatures. But is that going to exacerbate our labor issues?
Yeah, I don't know. Could be.
Ben, have you seen that phenomenon at all in the last 30 years?
Well, it's mandated by law now that for health and safety reasons, there has to be an area that is shaded in a field so people can get in out of the sun. Mandated that there's porta potties close to them. It's mandated that there's water available. So it's, working in 118-degree heat is not fun, but, and in fact, people are let off work early when temperatures do get up there. So there's some adjustments that have been made to make it a more habitable work environment.
So there is a question at the top here from an anonymous attendee about research looking into freezing and low temperature information for California, especially in light of the recent Texas winter storm. It's reminding me actually of a post on that Daniel Swain, our panelist from yesterday, posted on his Weather West blog, in which he explained in great climatic detail how a Texas winter storm could never happen in California. So for whoever asked that question, if you're still on the call, I would encourage you to look back at that blog because it's pretty fascinating. With that said, we have discussed chill hours and the low as well as the high ends of temperature. I don't know if anyone wants to speak any more to this particular point.
Well, I mean, just to say, I mean, yeah, I haven't seen that post, so I will definitely look and see. But I think, even as I said about this frost and overall exposure might be reducing, you might still get, 1 or 2 out of those 10 years with hard freeze, and that could potentially damage some of those crops. So it's not, the natural year-to-year variability will exist, even with the increase might be, or the risk might be lower. But yeah, so that's kind of the year-to-year variability as opposed to the long-term change.
Any additions to that, Ben?
Well, again, they're planting avocados in Peru. So that shows you, actually growers are risk takers. I mean, they're gamblers. They're out there, oh, I'm going to make a pile of money. And the land is cheaper out in Peru. Well, it's cheaper than it is on the Oxnard Plains. So, they'll find a vacuum and move in, and they'll work that ground until it freezes or gets too hot, or, the market collapses on avocados. It's amazing. I've always wondered how calmly growers take a freeze or a heat spell. They go, oh, I lost money this year.
So Jose has 2 questions. It looks like Sabrina is starting to answer the second about pest populations. And the first contains some themes we've already discussed, places elsewhere in the world that might be positively impacted by climate change. I don't know if this group wants to talk at all comparing California to other regions, whether we're better adapted to be resilient given the diversity of crops we already have, or if we're more vulnerable given our kind of water situation. But then also maybe can speak to, Ben, you've mentioned a couple of times Michoacan outcompeting us in blueberries. Is that a function of them suddenly being able to grow blueberries because of their changing climate, or is that just is there a different explanation there, whether it's a new variety or a changing market?
We did all the work on evergreen blueberries right here in Ventura County. And a company that I won't mention went down to Michoacan and adopted all the techniques that we developed here. I gave a talk at a Master Gardener training session about 25 years ago. And somebody said, well, how come we're not growing blueberries? And I said, well, you can't grow blueberries in Ventura. Our soil pH is wrong. We don't get enough chilling. And it turns out this is a great place to grow blueberries. And we worked out all the technology that allows it to be grown in Michoacan. Michoacan, I think in the local language means land of eternal spring or something like that. So it's, it doesn't get too hot, doesn't get too cold. It's just perfect for blueberries. So, but we grew lima beans here for years. We grew, we used to grow all kinds of things that we no longer grow. I mean, agriculture is adaptive. I think folks here are ready to take on new challenges all the time.
Tapan, is California more or less resilient compared to other regions globally? And I'm sure it depends because other regions will be impacted differently, but can you speak generally to that prompt?
I think in general, what we are growing is what, nutritionally rich commodities. And so when you think about from that nutrition perspective, we have so much diversity than any other state or country. And I mean, the diversity that we're growing. So that itself makes us more resilient than other regions. But that said, I think, all the regions have their own opportunities and constraints and challenges. So, water being one here, but then we have technology, we have some innovations, and I think it's kind of the dynamic process. But the types of crops that we can grow here, that's probably to our advantage compared to other regions, I think.
Thank you. Sabrina, I hope you're still able to answer Jose's question about pest populations. Neil, I might, just given the specificity of your prompt, I might encourage you to reach out to Nikki directly to talk more about cover crops. I'm going to jump around just a little bit. We have just a couple more minutes. Susan offers an interesting prompt. Can we have crops harvested at night instead of daytime? I don't know what the constraints are that would require, that insist that it's done at day other than daylight, but is there any advantage to a production change like that?
In the Imperial Valley, they start work at 2 in the morning and work until it gets hot. So yeah, you just have to have floodlights.
Yeah, and I think especially their window is just shrinking too, and so I think it's it's more intense working environment in those kind of regions. But yeah, I heard that I heard that probably 5 in the morning is where it starts. So 2 is a new thing for me.
So Benjamin brings up this tension between monoculture and diversity, talking about how diverse farms are more resilient farms. Wondering if you guys have any thoughts about this. I think we've just discussed how California has a diversity of crops, but that doesn't necessarily mean that any one farm is itself diverse. Is there any advantage to either making production smaller as a way to adapt to climate change, or can we sort of persist in this monoculture paradigm?
Well, Cindy Fake, our advisor in Placer County did a study on the number of crops that people grew for the farmers market. And she determined that if you grow more than 5 crops, you can't keep track of it all. And so, you know, she talked to people that had 15 different, you know, varieties of eggplant and tomatoes and stuff like that. And, you know, it really takes a lot of thought, a lot of logistical organization to grow multiple crops. So, you know, most of our lemon growers grow avocados just because when the avocado market's bad, the lemon market's good, and vice versa. So, you know, there's a certain amount of that going on. You know, it's mainly the veg crop annual plant growers that probably have more diversity than any other group of growers, or the flower growers. They're all flowers, but they're all different.
Have you found diversity at that scale, Ben, to buffer producers from sort of economic catastrophe in the past?
Exactly. Yeah, that's why they do it.
And I think that there could be more of a risk management technique for small scale growers as opposed to the large scale conventional growers, right? And so, I mean, I saw there was an interesting comparison of list of priority adaptation by small scale versus conventional, and diversifying your farm was one of the leading recommendations from small scale growers perspective, but nothing on the conventional side.
Well, Benjamin, I don't know if we satisfyingly answered your question, but at least we tried. And we have this last question about, you know, given the future of California, what would you grow? We've sort of already asked and answered this question. I think, Ben, you emphasized that it's still good avocado and citrus ground here, in, at least in Ventura County and Tapan. Maybe it's too specific of a question to answer statewide. And so unless there's anything else that comes up in the Q&A in the next 20 seconds or anything else from the panelists, I think we can wrap up.
Yeah, you find the market first, then you grow into that market. You know, I was here for about 6 months and I got a call from an apricot grower up in Ojai. I need to sell my apricots. I'm going, you should have figured that out long before you had to harvest them. So thank you, Matthew.
Thank you all.
Matt.
I hope that folks found this to be an engaging and useful conversation. Given the fact that we're a half hour over, I'm pleased to see that nearly a third of folks stayed with us, although that number is dropping quickly. Thank you again to our panelists for taking the time. I really enjoyed the conversation, and thus concludes the second installment of our 3-part webinar. Thank you to our program support staff as well, and to Annemiek for having the vision for putting this all together.